And in fact, many univariate tests, univariate means no-regression form of test, t-test is one of them, and come with non-parametric test. So instead of log transforming data, you might directly compute these two medians. And to do that, and we will proceed to perform Wilcoxon rank sum test. Okay, so let's talk about non-parametric test of Wilcoxon rank sum test comparing two medians. And in t-test, as you remember, t-test compute the ratio of actual average, right? Average between the two group as a numerator, and then denominator would be a standard error of those difference in averages. So using a mean and standard error, instead of doing that, and here Wilcoxon rank sum test use the ranks of data. So this is hypothetical data, and let's see, you have 6 patients and they survived in hospital, and you have another 6 patients who died in hospital, and you have a total hospital cost unit is 1,000. So this is $300,000, and you have this as outcome. So you want to compare median of these two groups, okay? And many non-parametric tests and use ranking of data. So what you do is you rank this 12 data points from lowest to the highest. So 20 is lowest, you rank as 1. 51 is second lowest, you rank as 2. And 90, the third lowest, you rank as 3. And you repeat this to the highest point of 954. That's rank 12th. Okay? And then you compute sum of the rank within group 1, survived group, and sum of the ranks within deceased group. Okay? And then you compare these two sum of the ranks. Okay. And if survived patient, deceased patient have higher total hospital cost, and ranking should be higher. So you actually compute the p-value comparing sum of the ranks between two groups. So in this example, 40 and 38 is not a large enough difference, so p-value might be large. Okay, so that's why, and we call this as rank sum test. You rank data first. Within each group, you compute sum of the ranks. Okay, so good thing about using rank is ranking is very robust about data distribution. So let's say if you have total hospital cost and this survived in deceased group, and this is an outlier, the majority have a smaller value. Okay, and similarly here, you have 1 or 2 or 3 outlier. Okay, and if you rank from lowest to highest here, this would be number 1, and this could be, let's say, 1/50th. Okay, and when you have an outlier, and this value is 150 rank, right? But when you don't have an outlier, let's say instead of having this outlier, and you have data here, okay? And then this is the highest, and you put it at 150th ranking. So as you see, how big is outlier does not really change ranks of data. Okay, so therefore using ranks and results are more robust for outlier, and i.e. shape of data, a data distribution. And on the other hand, t-test use mean or standard error, right? Standard error is based on standard deviation, and those are highly influenced by outlier. So the results are valid only when you have normally distributed data, although any test using ranks, and ranking doesn't depend on shape or distribution of data, and therefore we call it non-parametric. It's a distribution-free statistics. Distribution-free means you can go ahead to use non-parametric test and for normally distributed data. So, in fact, in my practice, and I don't use t-test, I use Wilcoxon rank sum test all the time because it's also valid for normally distributed data. And using non-parametric data, it's distribution-free, so we don't have to worry about distribution of each variable to decide what test we should be using. Instead, you can use non-parametric test for everything, okay? And I'll later show you how to do this in R, when you do Wilcoxon rank sum test in R. And here is a p-value, which is less than 0.05. So we use this as evidence to reject the null hypothesis. Therefore, we might indicate there is a difference between the two groups. So when you do non-parametric tests, and we usually put the median value. So you can say total hospital cost is 47.080 dollar in deceased, and it was 27437 in survived patient, and then difference was statistically significant, p less than, we better not to say less than p equal, we better to put exact value of p value, in this case 0.00026. 0.00026.